Today we're going to talk about absolute value. What is an absolute value and what does it do? Absolute value has similar properties to square root. It's not going to operate like the square root, but it has a certain property. The outcome of absolute value is always a positive number or zero. So I can say whatever comes out of the absolute value must be greater than or equal to zero. Similar to the square root, we had outcome is always greater than or equal to zero. But the difference between absolute value and square root is that you can have positive or negative number inside the absolute value. But if you do that for the square root, then you would get complex number. You cannot put negative number inside the square. So what we focus on is that the outcome of the absolute value is always non-negative. That's the similar property that it's in common between square root and absolute value. So what do we say? Absolute value of x is always greater than or equal to 0 for any real value x. Now, sometimes you're given an absolute value equation and you want to figure out how to solve that absolute value equation. So if you have absolute value of x equal to a, here are the two results that you can get. Either x equals to a or x equals to negative a. This is if a is positive or non-negative, it could be 0 as well. So since the outcome of absolute value again is non-negative, that a must be a positive, must be a non-negative value. Think about it this way. Let's say you have absolute value of some number, and I'll give you that number, and I say that number is 3. What can you put in here? You could put it 3. It could be positive 3 or negative 3. So if I give you an absolute value of a number and say this is a, what could you put in here? It could be a, it could be positive or negative. So this is what we have. We have x could be a or x could be negative a. But if I write absolute value of some number equals to negative 3, there's no way that you can put something inside the absolute value and the outcome becomes negative. So this has no solution. It's not possible. So we have this restriction that outcome of the absolute value must be a positive or a 0. Here are some examples. Solve these equations. Absolute value of x equals to 3. Think about it as, what number do I put into absolute value to get 3? Either x equals to 3, or I could replace the negative 3. They both give me the same outcome. So whatever you have inside the absolute value is either equal to that constant or it is negative of that constant. How about 0? I can say x is 0 or x is negative 0. But it doesn't really make any difference, positive or negative 0. So it's only one solution. You can have two solutions, one solution. Or where do I get absolute value to be negative number? It is never possible. Whatever number you replace inside the absolute value, the outcome must be positive. You can never have negative 2. These are the very basic ones. Here, a bit slightly, we're going to progress into more complicated absolute values. So here is an example. If you have absolute value of 2x minus 1 equals to 3, what can you think? Think about this inside to be one number. What number it could be? It could be 3 or it could be negative 3. This whole thing, 2x minus 1. So I can say 2x minus 1 could be either 3 or 2x minus 1, it could be equal to negative 3. You always set up these two statements and you solve each one. 2x minus 1 equals to 3. What is x? 2x equals 4. X equals 2. Or if you solve the other one, you'll get 2x equals negative 2. Therefore, x equals negative 1. And again, you always check your solution. I replace 2 into the absolute value. What do I get? I get absolute value of 2 times 2 minus 1 is 3. Is it equal to 3? Yes, it is. I replace negative 1. 2 times negative 1 is negative 2. Minus 1, it becomes negative 3. Is it equal to 3? Yes, it is. So both of these two, x equal to 2 and x equal to negative 1, are acceptable. These are two solutions. Again, it's not always possible that you have two solutions. You have to make sure that you check your solutions. How about this one? 2 times x, absolute value of x minus 5 equal to 1. You always isolated the square root if you remember. you always isolate the absolute value as well. It's the same structure. This is very common. If you're solving an absolute value or square root, you always want to isolate. So what do? I add 5 to both sides. I'll get 2 absolute value of x equals 6. What is the absolute value of x? This both sides divide by 2. I can do this. Becomes 3. Where do I get absolute value of x to be 3? Either x is 3 or x is -3. Whatever the inside of the absolute value is must equal to 3 or -3. In this case, x is only inside. So do I get these two solutions both to satisfy the equation? You can always check. 2 times absolute value of 3 minus 5, is it equal to 1? 2 times 6, 2 times 3 is 6 minus 5 equals to 1. So this works. That's a solution. If I replace -3, 2 times absolute value of -3 minus 5 equals to 1. 2 times -3 is -6, but you cannot do that. You have to take the absolute value. The absolute value of -3 is 3. 2 times that becomes 6. Minus 5 is 1. So this is acceptable as well. These two are two true statements. Again, absolute value is no different than square root. You always isolate. Here, absolute value of x plus 2 plus 5 equals to 0. I can say absolute value of x plus 2 equals to -5. I'm isolating. If you remember when we had square root, on the other side you cannot have a negative number because it would have gave you no solution. But we would go through the process and to see if it does happen. In this case, I can say the same thing. Absolute value can never be negative number. So at this point, I should say no solution. But if you make a mistake and say this inside could be 5 or -5, if you can say x plus 2 is 5. Again, this is a mistake, but if you do it, or x plus 2 equal -5, if you do this and solve each one, this would give you 3, the other one give you -7. Now, when you check your solution, you will notice that if I replace 3, what do I get? I get absolute value of 3 plus 2 plus 5 equal to 0. This is 10 on the left side, 0 on the right side. So this is not true, false statement. Therefore, this is not acceptable. If you try -7, absolute value of -7 plus 2 plus 5 equal to 0, you might say, oh, this works. It doesn't work because -7 plus 2 is -5. Absolute value of that is positive. This is positive 5. Then plus 5 is 10. 10 does not equal to 0. So this doesn't work either. So checking the solution is always a good idea. Sometimes you make a mistake. So no solution. But you could have said that from the beginning because absolute value can never be a negative number. Okay, how about this one? What if you have variable instead of constant outside the absolute value? Similar idea. You isolate the absolute value. You say 3x plus 4 equals x. Okay, when do I get this absolute value to equal x? It is either when 3x plus 4 is x, they're both equal, or 3x plus 4 is the opposite in sign. It is -x. If it was 5, you would say equals to 5 or equal to -5. The same thing, if it's a variable on the other side, you would say either equals x or equals to -x. Let's solve each one separately. 3x plus 4 equals x is a linear equation. You'll get 2x equals -4. I'm going to skip ahead and say x equals -2. Hopefully there is no problem to solve these. And if you solve the other one, you'll get 4x equals -4. Therefore, x equals -1. Do I check my solution? Absolutely. You always check your solution. So check. I replace -2. What do I get? 3 times -2 plus 4 minus -2 is equal to 0. 3 times -2 is -6 plus 4 is -2. Absolute value of -2. -2 is +2 equal to 0. Is it true? Not really. Absolute value of -2 is +2. This is +2. Positive 2 plus 2 is 4. So this is not an acceptable solution. What if I check the other number? 3 times negative 1 inside the absolute value plus 4 minus negative 1. Is it equal to 0? Let's try it. If we have 3 times negative 1 is negative 3 plus 4, it becomes 1. So you'll have positive 1, absolute value of that. Sorry, I have such a bad handwriting for some reason. Plus 1 minus 1 becomes positive 1. Again, you will have 1 plus 1, which is not 0. So this is not acceptable either. In this case, I got no solution. Neither one of the solutions that we found were acceptable. So it's not always possible to say it from the beginning. You have to go through the process sometimes. But if you don't check your solution, you make the mistake of accepting those as your real solution. What if we had two absolute values? Remember what you do for square roots? You do exactly the same idea. I isolate this absolute values and say 2x minus 5. Absolute value of x plus 1 equals absolute value of 2x minus 5. Think about this. If you had absolute value of x equal to 2, what does it mean? It means, let me go back. Let's say if you had absolute value of x plus 1 equal to 2. What could you say? You would say this inside x plus 1, the whole thing must be either 2 or must be negative 2. It could be positive 2 or negative 2. So you will set it and say x plus 1 is 2 or x plus 1 is negative 2. This is what we do. So here, this insides must be equal to each other, and they must differ at most by a negative sign. If the left-hand side is 3, right-hand side could be negative 3. If the left-hand side is negative 5, right-hand side could be negative 5 or 5. So what can I say about this is, let me erase this part, is that I can simply set up this equation. Say either they're equal to each other exactly, or they're opposite of each other in sign. X plus 1 equals negative 2x minus 5. They're either equal to each other or they diff their opposite values. Left side is 5, right side is negative 5. So the difference would be either, it would be only a negative sign. Each one is a linear equation. You can solve each one. X plus 1 equals 2x minus 5. You can move the stuff around and get x equals to, I'm going to skip ahead, x equals negative 6, I believe. Or maybe positive 6. Yes, positive 6. And right-hand side, you distribute this negative. Don't forget that. You'll get x plus 1 equals negative 2x positive 5. And then now if you solve, x becomes negative 4/3. Looks like positive 4/3. Maybe I should have done this so I'm sure that I don't make any mistake. So add the 2x to both sides, you get 3x. Subtract the 1, you'll get 4. What is it? X equals 4/3. And finally, check the solution. Right here. Check the solution. Check. Where do you check it? You always go back to the original equation. It was absolute value of x plus 1. X is 6 in this case. 6 plus 1. Is it equal to absolute value of 2 times 6 minus 5? I'm replacing it back into this original equation back here. Oh, sorry. There was a negative sign in between. Let me fix that. So it's minus that equal to 0. 6 plus 1 is 7. So you have 7. Absolute value of that is still 7. Minus 2 times 6, 12 minus 5 is 7. Absolute value still 7. 7 minus 7 equals to 0. Yes, therefore x equals to 6 is acceptable. If I try 4/3, what do I get is absolute value of 4/3 plus 1 minus absolute value of 2 times 4/3 minus 5. equal to 0. Make sure that you're comfortable with fractions, because at this point it's just numbers. You cannot multiply 3 and say, okay, let's rationalize. Just numbers, you can add them up. 4/3 plus 1, that could be written as 1 is 3/3. Common denominator. It is 7/3 minus absolute value of 7/3 is still positive 7/3 minus 2 times that is 8/3. This is absolute value of 8/3 minus 15/3 is negative 7/3. Is it equal to 0? Absolute value of negative 7/3 is positive 7/3. 7/3 minus positive 7/3 is 0. This works as well. So x equal to 4/3 is the solution as well. So I have two solutions, 6 and 4/3. As you see, there is not much difference between how you solve this equation and square root equation. In the square root, you squared. In this one, you have to check if the insides are equal to each other or they're opposite by a sign. So here again, I have x plus 4 equals x minus 7. Either I have x plus 4 equals to x minus 7, either the insides are equal, or they differ by a sign. X plus 4 is the opposite of x minus 7. Okay. Solve each one separately. Left side, if you subtract x from both sides, what do you get? You'll get 4 equal to negative 7. That is a false statement. This is a false statement. So what can I say? I can say the left side has no solution. How about the other case? The other case is you distribute the negative. You'll get x plus 4 equals negative x plus 7. Move the x to one side, so you'll get 2x equals 4 and 7, 13. Sorry, 11. X equals 11/2. Is it acceptable? We don't know. You have to check your solution. Check. If you replace 11/2, you'll get absolute value of 11/2 plus 4 equals absolute value of 11/2 minus 7. If you do common denominator, 4 is 8/2. 7 is negative 14/2. 11/2 plus 8/2 is 20/2. Absolute value of that. Right side is 11/2 minus 14/2. One second, I think I made a mistake. Instead of 7 minus 4, this 11 should be, sorry, this 11 is not correct. 7 minus 4 is 3. This is supposed to be 3/2. Sorry. Yeah. For some reason, I think I'm tired already. This is supposed to be 3/2. Okay, so this is not 11/2. This is, let me erase this part just to check our work. Yeah, sometimes I make mistakes as well. Well, it's more often than not. Okay, let's replace 3/2. 3/2 plus 4 equals 3/2 minus 7. Is this true or not? 4 is 8/2. 7 is negative 14/2. 14/2. Okay, 3/2 plus 8/2 is 11/2. What's the value of that? 3/2 minus 14/2 is negative 11/2. Are they equal to each other? Yes, absolute value of 11/2 and absolute value of negative 11/2 are equal. So therefore, 3/2 is the solution. So what is the solution set? Even though left side had no solution, we found the solution from the other equation. We got 3/2. So we have one solution, it's 3/2. Okay, how about this one? In the last example, it was x plus 4 equal to absolute value of x minus 7. How about if x plus 4 equals negative x minus 4? So what do I say? Again, in the double absolute value, you always, the interior must equal to each other, or they must differ by a sign. If either x plus 4 equals negative x minus 4, or x plus 4 equals negative times negative x minus 4. They differ by a sign. Left hand side, left equation is x plus 4 equals negative x minus 4. Add x and divide by, you'll get 2x equals minus 8, x equals negative 4. And right hand side, you'll get x plus 4. If you distribute this negative sign, what you get is x plus 4. If you subtract x from both sides, what you get is 4 equal to 4. Here's an important part. You have a true statement. It doesn't depend on x. So what can I say? If you remember, we had this case of if you have a true statement always, you have infinite solution. You don't need to find out exactly what are the solutions. You can say there are infinite solutions. Sometimes they ask you what are those solutions. So how do you find it is you see these two numbers, x plus 4 and x negative x minus 4, they only indicate if they're opposite sign, then they will have infinite solution. So if I pick, let me show you an example. Let's say, by the way, in this case, what is the solution set? Solution set, there are infinite of them. Infinite solution. Not infinity, there are infinite solutions. But let me show you that if you try something like 2, just pick a number, since there are infinite solutions. What do you get? Is 2 plus 4? Is it equal to negative 2 minus 4? Yes, absolutely. 2 plus 4 is 6. Right hand side would be absolute value of negative 6. This is true. How about if I try negative 5? Negative 5 plus 4. Is it equal to negative 5 minus 4? Is that true? Negative 5 plus 4 is negative 1. Right hand side is negative 9. Here's, these two are not equal to each other. If you try something like 3, 3 plus 4 equals absolute value of negative 3 minus 4. Right hand side is negative 7, left hand side is 7, but with the absolute value, these two would be equal. So you see that 2 and 3 will work, but negative 5 does not work. Maybe you cannot put negative number in there. Maybe that's the problem. So let's try something like negative 1. What do you get? Negative 1 plus 4. Is it equal to minus 1? Oh, by the way, I think I made a mistake. This is 5 minus 4. So negative 5 would have still worked. I think I made a mistake. Yeah. If you replace negative 1, it will still work. We get 1 minus 4. You'll have 3 and negative 3. You don't need to find out all these numbers. You say infinite solutions. Later on, we will specifically discuss how you find out what type of solution. You can pick numbers to see, is it always the cases? Sometimes there is a restriction on the domain. So since we haven't discussed functions, I'm not gonna go into detail. So in this case, we have infinite solutions. Okay. Here, this is maybe the last one of the types of absolute values. There are more cases, but our textbook focuses on only these cases. And since we haven't discussed functions, so I'm not going to get into this, but it's very important that you know how to solve a absolute value, because when we discuss inequalities involve absolute value, you need to know how to solve the equations. Always knowing how to solve equations simplifies the work for inequalities. And next time, this is what we're going to discuss. So let's stop here.